I will begin with a word of prayer once I get up here. So, Dear Heavenly Father, we thank you again for this day, for the beautiful weather outside. I thank you for these students. Just ask you help us to use this time wisely to just address any questions that remain and just help them to do well on the test Wednesday. Just that you be glorified in whatever they do, Lord. In your name I pray. Amen. So, today is for your questions. Do you guys have any questions in particular? Yep.
Is the test going to be like the same format as this, or is there going to be a lot of differences?
Pretty similar. A little bit different. I'm going to probably make the test slightly shorter. Probably going to add a sentence or here or there on the instructions to try to corral you guys into the right way of doing things. Like, for example, here in problem 4, I'm likely to add a sentence that says, find the solutions, real or complex, of the following quadratic equations, period. Simplify your answers for full credit, because I don't want to be looking at half-completed quadratic formulas that haven't been worked out, which is about like 30% of the class. It's really hard for me to decipher whether or not you're totally wrong or totally right, so I'm going to force simplification on these problems, that problem. Now, generally speaking, I don't fuss too much about simplification other places. Sometimes people do, but that, I'm going to add a sentence there.
With the stuff that we did last week, will there be more of it, or is it the same amount?
I think there will be more, there is likely to be more on the nonlinear inequalities than's on this test, so there might be a little bit more of that. I think that's possible. Because yeah. Okay, so, yep.
On the test, for the formula sheet, is it one page or?
You're allowed, again, one page front and back. Yeah. It can be handwritten, it can be typed. I guess if you really wanted to, you could like paint it, but it seems like a lot of work. Other questions? I talked a fair amount about the factoring problem at the start of the quiz, right? Last Friday. So we already talked about that some. I would expect that the factoring tests all of the same things that this does. I would expect that everything that's tested on quizzes A and B will be tested on the test. So I will find a way to put everything that was on either quiz on the test, most likely.
So it's not going to be like a completely new type of problem that we've not seen on these before, or is it?
Probably not. I can.
No. Yeah.
You want something fresh?
I was just wondering if it was like kind of like the same problems and like different numbers, or if it's going to be like a complete rewrite.
See, that depends on what you think of as a complete rewrite, but but yeah, pretty much same patterns and same format is what I aim for. I want the format not to be a shock to you, right? I'm expecting you to write your work on the paper, to box your answers, that sort of thing. So it might actually, again, be 4 pages, but I might just reduce the number of problems so there's like more white space. That might be what I do. I am planning to shorten it a little bit because of the complaints from one of the sections. So I don't think it was too long. I'm pretty sure if you didn't finish the quiz, it's because there was something you didn't understand, right? All right, so let's talk about this one here. So here, basically factor out the minus, and then we could cancel the t minus 2 to leave us that. Part B, you just made a common denominator. All right. We already talked about the factoring stuff last Friday. Problem 2, notice that, so just generic advice, if you did take quiz A, make sure that you also take quiz B. You want to make sure you have taken both of them before the test, right? Make sure you study both quizzes because there are some different problem types, right? Like this one was on quiz B, but it wasn't on quiz A, right? But it's simple enough. You multiply by the reciprocal, you cancel out like factors. You have to, you know, y to the 11th over y to the 4th is y to the 7th, and this simplifies.
Would an acceptable answer be 2y to the 7th over 3? Or do you have
Yeah. Oh, yeah. 2y to the 7th over 3. That would be the same answer. Yep. Yep. Here again, we make a common denominator. It gives you that. All right. So let's talk about problem 3. Most of you guys are getting problem 3 wrong. Like most people. I don't know. 80% of the class. I do want you to learn this. Like completing the square will be on the next test. It will be on the third test probably. It will be on the final. It's going to keep reappearing over and over and over again until you learn it. So please learn it now. Okay, so this one, how did it go? We take half of 10, which is 5, right? And then we have to subtract 25 because 5 squared is 25. So that right there is completing the square, at which point you see you've got minus the number, right? So x plus 5 squared minus 29, and then 29 is the square root of 29 squared, so we can get this, and that's that. Yep.
Does the sign for C determine if it's a plus 25 or a minus 25? Or the sign for B?
The sign for B, all right, here, let's see if I can, here's another one. So if I had like x squared minus 26x, let's say, you know, plus 2. So to complete the square there, I would do x minus 13 squared. The square of 13 is 169, so I do minus 169. And I still got my plus 2. So I got x minus 13 squared minus 167. And so then here it is, x minus 13 plus the square root of 167. X minus 13 minus the square root of 167. Sorry, I'm up against the board here. Oh,
So-
can you guys see it?
Okay, so it doesn't matter if B is positive or negative, it will always be a negative?
You always add half of the coefficient of B, whatever it is. If it's a negative number, you're adding a negative number. If it's a positive number, you're adding a positive number. But it's always half of the coefficient of B that you add. Yeah.
At the start of it, do you equal it to 0?
No. There's no equals to 0 here. This is a factoring problem. So no, I don't set it equal to 0. And there's a reason for that, because sometimes you can't, right? There's a problem later in the test. The formula is like this, yeah? This is f of x. And the question is, what's the domain, right? So to understand that, what you want to do is to complete the square in the denominator. Or at least one way to understand it is that. Because if you do complete the square in the denominator, what you can see from that is that this polynomial is prime. Like the polynomial in the denominator is prime, right? Which shows you then that the formula works for all x. That shows me that the domain for that one is, you know. So the reason I'm mentioning this is because we can't always set it equal to 0. Sometimes we're faced with a quadratic which isn't part of an equation, it's part of an expression, right? So we can't be adding things to both sides. We have to complete the square in the isolation of that one expression. Like we don't have the freedom to add things to both sides. Now there are other problems where you can, like this one here, right? You could add things to both sides here because it's an equation. But the difference is that's factoring. Expression versus equation.
So like you still use the same like formula for it, you just don't use it with the
Still use the same Basically the same algebra steps, yeah. Here, let's look at another one. So you guys need a little bit more work with completing the square, right? Let me show you like a little bit more complicated one. I think this is a useful example. 5x squared plus 14x plus 8. Let's try to factor this using completing the square, and if possible, okay? And over here, let's say 2x squared, plus 8x plus, I don't know, 10. All right. The instructions for both of these examples is factor, if possible, factor over r, if possible, via completing the square. All right? So the wrinkle here I'm adding is that it's possible it can't be factored, right? So maybe one of these is prime. Let me do the second one first because it's easier. So the second one, what do you do if you have something like this? You just factor out the 2, right? So we have 2 times x squared plus 4x plus 5. One of my favorite quadratics, this one. I complete the square on this. And what happens? If after you complete the square, right, you get a positive number added to your square, what's that mean? That means that this is a prime polynomial. In fact, you can't factor it over the reals anyway, right? You need complex numbers to factor it. And while I do ask you some questions that have complex numbers in the solution, I don't ask you to factor a complex, and using complex factors, right? That was not a question I asked you on the quiz. It's not a question I'd ask you on the test. Not yet anyway, right? Because you can't factor it with reals. In contrast here, well, it's a little bit further. Let's look at this one. In contrast, this one, after I completed the square, negative number. See the difference? Minus. So when it's minus, I can rewrite that as the square root of square. Right? And then I can use the, a squared minus b squared equals to a plus b, difference of squares formula, to rewrite it like this. That's the pattern that's going on here.
So if you're adding it, then you can't go any further, so then that's what's
Right. As you complete the square, once you've completed the square and you've collected all the constant terms outside the square, if the net result is a positive number, that means it's a prime polynomial. On the other hand, if after you've completed the square and you're left with minus a number, that means it can be factored because you can fall back on writing it as a square root of something, a square root of real number squared, which then factors like that. It may or may not be a nice number. So then a question other people ask me in other sections like, well, does completing the square, does it ever give you a nice number? It does. Sometimes the thing you end up with is actually a square, so to speak. So like this one's going to work out like this. This is a nice problem in that regard. But just to take a step back here, there are 3 things that can happen when completing the square, right? Either you complete the square and you have a net negative after the square, or you have a net positive after the square. What's the other thing that can happen? In between negative and positive, you have 0, right? So like something like that would be this. So x squared, plus, I don't know, 20x plus 100, right? So you take x plus 10, you square it, right? Half of 20 is 10. You have to subtract the square of 10, which is 100, right? So minus 10 squared plus 100. But what is minus 10 squared plus 100? I mean, they're equal, right? Those cancel. And so what does completing the square do in this case? completing the square in this case just straight factors it. Right? Completing the square in the case that it is a square will just factor it for you. Right? Because this is exactly, you know, x plus 10 times x plus 10, right? Completing the square always works. It is a foolproof method if you can do arithmetic.
Can you
Factoring, on the other hand, is dangerous because it involves guesswork. But it's easier because it's more clever. Yeah.
could you show us how to get from the answer to factoring?
Yeah, I'm not going to do that right now. We'll do that later. But that's also like a it's a friend Francisco, right? You're asking, can you work backwards from the answer?
Yes.
And the answer is yes, of course we can. That's really what's called the factor theorem. The factor theorem says that x minus c is a factor if and only if f of c is equal to 0 for a polynomial. But I haven't taught it that way yet, and I'm going to stay away from that for today. But you're right. I mean, you can use the quadratic formula to find the solutions and then work backwards from those to factor. You can do that. That's how I used to factor before I learned to complete the square. And I learned I was doing it the wrong way. But anyway. Well, wrong is perhaps too strong a term, but it's certainly an inefficient way. Okay, so this one here is a little bit tougher, right? But we can use completing the square to solve this as well. So factor 5 out, all right? And what do you got? You've got x squared plus 14 over 5, right? X plus 8 over 5. You're like, I didn't think you could factor a 5 out of 14 and 8. Well, you can. You just got to use your imagination. All right? There it is. Now what? Now we can complete the square. So, all right, we're going to do that. So I need to take half of 14 fifths. What's that? Half of 14 fifths is what? 7 fifths. 7 fifths. So x plus 7 fifths. All right? I have to subtract 7 fifths squared. And I still, of course, have my 8 fifths riding along. Let's do the math. What is 7 fifths squared?
49 over 25.
Right? So this right here, I'm going to do some math over here. So we've got minus 49 over 25, right? Plus, what's 8 fifths in terms of 20 fifths? It's 40 over 25. So I have minus 49 over 25 plus 40 over 25. So lo and behold, we have 9 over 25, minus 9 over 25, right? So the minus is important because the minus means that we can factor it. Right? Now, this one, unlike the other ones we've done today, for the most part, except for that one, what's the square root of 9 over 25? See, we can write that as a square root of that squared. What's the square root of 9 over 25? 3 fifths, right? Square root of 9 over square root of 5. So really what this is, I'm writing more than I need to, but I'm hoping I'm writing enough that you're not lost when I do it. 3 over 5 squared. Again, we're back to what? Difference of squares. So we can use the a squared minus b squared is a plus b times a minus b formula, right? And here it is. X plus 7 fifths plus 3 fifths. X plus 7 fifths minus 3 fifths. What is 7 plus 3 is 10. 10 over 5 is 2. And 7 minus 3 is 4. So we have x plus 4 fifths over there, yeah? There you go. We have factored by completing the square. This is an algorithm. It didn't involve guesswork. Each step is clear once you understand the algorithm. Factor out the leading coefficient. You take half of the coefficient of b, you add it to x, you square it, you subtract the square of that number, collect things together, make any arithmetic you need to clean up the number, and then you do the difference of squares, which always works. Unless it's plus, right? In which case you stop because it's prime. Now, we can do some, let's do a little bit more here though, right? What happens if you multiply this 5 through? What do you get? Right? So, of course, this polynomial, right, you could straight factor to this. By what? Right. I mean, yeah, essentially you go 5x squared plus 14x plus 18. Like you said, split the 5. And now that we have the answer in front of us, you know what to do. But some of you got stuck on this on the quiz, right?
It's the x plus 2 times 5x plus 4, is that the like definite right answer, or could it be the one before that too, with the on the outside?
Oh, yeah, either of these are factored, yeah. Either's fine. So, I mean, this just direct factoring requires, you know, a little bit of luck.
It's 8, not 18.
What's that?
It's plus 8, not plus 18.
Plus.
Put 18 on there and put 8 up there.
Oh, thank you. Oh, no. Yeah, don't do that. I was about to get really confused. So, plus 2, right? So, this is usually true in life. The more clever solution is easier, right? But unfortunately, if you're not clever with respect to a specific problem, it's good to have something to fall back on, right? Completing the square is not clever, but it always works. But it does require attention to detail and arithmetic, right? And some of you are going to get hung up on that. So like a lot of you, it's a trade-off, right? The trouble of the arithmetic of completing the square, that is a trouble for you. It's the same trouble that you have in doing the quadratic formula. Again, that's a problem of arithmetic that you're going to get hung up on. So this here, if you can hack it, is always better. Right? Yeah.
You can also use the AC method. Slide to the side, I think.
Yeah, I don't teach that. Let's see here. Yep. I know what you're about.
When you're doing the, like, when you got the negative 49 and 25 plus 40 over 25, how did you know that you were going to multiply the 8 over 5 by 5?
Oh, because I want a common denominator, so I'm like stuck with a 25th from the squared term, which forced me to put the 8/5 into the 40 25ths form. So Francisco's trying to get me to talk about slide to the side. I refuse. Yes.
Do you go over 2A and 6B?
2A and 6B. Yeah, let me put the thing back up. Anyway, so there you go. I've said my piece about completing the square. I wanted to spend some more time on it. Most of you don't get it yet. Take some time, figure it out. All right? I have enough of your points already. I don't want any more of them, you know? So, which point did you just ask me about? Number 2A? On version A or B?
A.
Was it this one? No?
Yes, please.
I was on B. This one. What about it?
Can you go over that?
Sorry.
Actually, we already have that.
That's fine. I can talk about it again. So, basically, this one?
Yeah.
So the key here is just that we have a t minus 2, we've got a 2 minus t. So we want to make those match. We know they're the same thing, but with a minus, right? So pull out a minus from this, we get minus 7 times t minus 2. And then I have the same factor, so I can cancel them. And I'm left with minus 7 over t plus 8. Yeah.
Question. If you multiply a minus 1 on the top, you don't have to do it on the bottom, right?
Right. Well, yeah, I mean, I'm not multiplying this by, I would say I'm factoring out a minus 1 from that expression, right? Like, I'm just factoring minus 1 out.
Wait, how did you hold that? Just needed to make it
Because because I know that they come in a pair. I mean, this is the same thing multiplied by -1. So I know that these two are going to cancel to give me -1, basically.
So you basically just cross them out and put a minus in front of the 7.
Can you
You want me to show you a different example that's similar but different?
can you just show the work for how you would have it?
That is the work.
Well, no, like,
I mean, there's nothing.
I mean, where did you factor out the -1?
Let me try a different example. Maybe that'll shake whatever's not loose, right? Let's see here. So, like 8 times 3 minus x over, I don't know, x plus 2 over x minus 3, all right? So this I can rewrite as 8 times -1 times, 3 minus 3 plus x, right? Oh, good grief, wrong. Minus 3 plus x. I'm trying to show work here that's different than what I've already wrote, but to me it's awkward what I'm writing. But I'm factoring the -1 out of here, because when I multiply -1 through, I get 3, and I get minus x. Then, of course, that is the same as minus 8 times x minus 3 divided by x plus 2 times x minus 3. These cancel. And I'm left with minus 8 over x plus 2. Yeah, I mean, I think, like, generically speaking, the pattern is this. A minus b over b minus a. Whenever you have that kind of pattern, you can rewrite this as, a minus b over minus a minus b, essentially. So you can pull that minus out, and then these cancel, and you're just left with -1. So, like, that's what that's...
Same for the numerator, too.
Right, yeah, we could have... Sure, you're saying you could have done, like, minus b minus a. You could have done that. Also true. Let me move on here. Any more questions about this part, or? Okay, that was a stretch. Okay, that's good. I mean, stretching is allowed. It's fine. It's fine. I welcome stretching. Let's see here. I think stretching in the middle of the test is, like, that's a healthy thing to do. Any questions about this one? Basically, if you've got a square equals to a number, we can use the square root property to solve it. If we're taking the square root of a negative number, that gives us a complex number. This problem is pretty much the only place where complex numbers are likely to appear on your test, this kind of problem, right? Problem 5. Somebody asked me in an earlier section, they asked me, is there any place where I should use the quadratic formula instead of completing the square? And I said, well, I mean, to me, there's not a unique answer to that question. They both have their place. But this problem is one where I used completing the square. See this? I got this quadratic formula. See that? And this is one of those ones where I did the both sides thing, right? See this? I subtract, well, actually I didn't. I never do the both sides thing. But here I completed the square on this guy, and then I moved everything to the one side. Well, I guess I didn't do that either. So I skipped a step here, and I got to that. And anyway, so my point to you is I solved this quadratic equation essentially by completing the square and using the square root property, more or less. It's kind of a mess, right? It would have been easier here, actually, to use the quadratic formula. So this is an example, weirdly enough, that has really nice answers, right? Like 10 or minus 12.5 are the answers here. And yet, just direct factoring / completing the square kind of method is kind of ugly, as far as I see anyway. But if you were to have used the quadratic formula, like maybe even back here, and worked it out carefully, you should have gotten 10 and minus 12.5, right? So maybe quadratic formula is a good option for, like, applied problems as a generic rule of thumb. Yep.
If we skip, like, a step on a test, we kind of have to show all work, or
No, this is more steps than you need to show here, but you do need to show steps, right? Yeah. Now, the other problem, the other applied problem, which was, what was it? So there's some of you are like, what's a successive integer? Well, we did talk about it in class, right? Successive integers are one comes after the other, like 2 and 3, or 5 and 6, or 25 and 26, or 1,000 and 1,001. These are successive integers, right? Now, the thing is, this is what I wanted you guys to do, right? X times x plus 1 equals to 24. And then if you work it out, you get, these, again, like I learned my lesson on the other one. Like, I'm going to just use the quadratic formula because it's kind of ugly. And so, anyway, I get minus 1 plus or minus the square root of 97 over 2. These are obviously not whole numbers, right? They're not integers. They're not plus or minus whole numbers. So the answer is no. Now, how did you guys solve this problem? You're like, well, 24 has factors, 1 and 24, 2 and 12, or 3 and 8, or 4 and 6. And if you look at that, there's no way you can multiply 2 of these factors to get 24, and such. None of them are successive integers, so it's impossible. And I was like, well, that's a complete solution, actually. That's completely logical. Like, you guys have given me what's called a number theoretic solution to this problem, and I can't reject it. It's mathematically valid. So what if you haven't used the methods I taught in this class, right? I can't deny it's a logical solution, so I didn't take off points if I felt like you'd written a sentence which was believable. So for that reason, this is not on the test because I can't grade it. Yeah.
My question is, I actually did what you said.
Uh-huh.
So I understood that as the product of successive integers that they are capable of doing that. Because these are successive
1, 2, 3, 4.
integers.
Oh, hey, nice. Yes. So Francisco has pointed out, bonus point, by the way.
What?
Ask me about that after class. That's worth a bonus point. I did not read your solution as it ought to be read.
Okay.
I see it now what it is. What he's saying is 1, 2, 3, 4 are successive integers, right?
2, 3, and 4.
Well, but 1, 2, 3, 4 are successive. Yeah, 2, 3, 4. They're actually two solutions, right? So 1, 2, 3, 4. 1 times 2 is 2. 2 times 3 is 6. 6 times 4 is 24. Those are. So he's taking 3 or 4 successive integers to get 24. Did I say the product of 2 successive integers?
Yes.
No, it does not say that.
I did not. So it just says the product of successive integers. There's an ambiguity there. See, if I'd said the product of a pair of successive integers, then you'd be up a creek. But I did not. I did not. Anyway, for this reason, this problem is dead to me because it does not assess the algebra that we're interested in. It just assesses your ability to avoid the algebra and use common sense arithmetic, which is lovely, but not the point of the test. So anyway, just to... Nice. All right, so problem 6. Oh, the things I saw here. I saw bad things. Bad things. Listen, guys, like if you have, the key is this, all right? If you have the square root of x plus 3 equals to 0, hypothetically, suppose you have this. Some of you are doing this. You're like, oh, so x plus 9 equal to 0. Therefore, x equals to minus 9, right? What you're doing is you're squaring each term separately. But this is not how algebra works, right? If you square this, what happens when you square this? You got to do this, right? You got to FOIL it, so you get yourself an x plus 6 times the square root of x plus 9. There's a middle term. You don't just square the terms and add them together. This is not how it works. There is a middle term. You must not forget about this. In fact, the problem is I have stated here the square root of x plus 3 equal to 0. That has no solution, at least no real solution. All right, so how do you avoid this problem? Well, one of the things you can do, sometimes it's unavoidable. Sometimes you just have to square a sum of things. And when you do that, you have to take care that you actually have to multiply it out, right? Don't miss the middle term. So here, that didn't happen for this problem. See, because so the first rule of thumb, when faced with a radical equation, you isolate the radical. I repeat, we must isolate the radical. So I isolate the radical, then I square both sides, right? After I square both sides, lo and behold, quadratic equation, factor it, find two solutions. Whenever you square the equations, you may be adding an extraneous solution in the process of squaring it, so we have to check. And in fact, we did, -5 is not a legit solution because if you plug it back in, it doesn't work. But 3 is, so the solution set just contains 3. 3 is our only solution to this problem. All right, yep.
The square root of x plus 3, could you subtract 3 and put it on the other side? And then, like, square it here on the bottom where you wrote it?
This one?
No, like on the board. Like,
oh.
Subtract 3 and then square it and get like a plus or minus.
Well, yes. Oh, yeah. Okay, this one, yeah, we get square root of x, square root of x equals to -3.
Yeah.
Really, once you have that, you should just stop. Because square root is non-negative. If you have square root is negative, game over, end of story, no solution. Square root is positive or 0. But you're right, we could forge ahead and square both sides, ignoring that, right? And that would give us x equals to 9, which would then tell me that, well, x is 9, right? And then you could try, is 9 the solution? Well, the square root of 9 is 3. Is 3 equal to -3? It is not, right? So that's extraneous. So in this case, that problem squaring, you've added a solution, just one solution, which was extraneous. There is no solution to this problem. No real solution. Now, in contrast, part B is a cube root. So the natural enemy of the cube root is the cube. You cube both sides. You get a -8 from -2 cubed. Again, quadratic equation. You factor it. You solve it. You get solution set 2, 4. Fun fact, cubing an equation or taking an odd power of an equation does not change the solution set. Like squaring it or taking the 4th power, you can squash minuses. So that's changing the kind of like possible solution set. That doesn't happen with the cube. So I can be assured that both 2 and 4 are still going to work. This one here, when we have absolute value, remember we got to try minus and plus, right? So you do that, you get -1/2 and -5/2. Now some of you also got -1/2 and -5/2 for the other version of the quiz. Why were you wrong? What was the other version? What was the difference? Let's look at it. -2. Oh, it's a trap. So the absolute value of 2x plus 3 cannot be -2. End of story. Game over. Stop. No solution. Now, if you solve the equations, 2x plus 3 equals to -2, 2x plus 3 equals to 2, you're going to get -1/2 and 5/2. It's just that when you plug both of those back in, neither of those solutions will give you back -2. But both of the solutions that you found will give you back 2. They're not solutions. Both of your solutions are extraneous if you have this problem. All right? So you got to watch out for that. Absolute value equal to a negative number, no solution. Absolute value less than a negative number, also no solution. Any question? This one's, I think, of all the questions on the whole quiz, to my taste, this was the hardest one. Because, well, for me, it's the hardest one because that quadratic for me was really tough to factor, And sorting through the quadratic equation for that would actually also be pretty tough without a calculator, Yep.
Would there be multiple versions of the test or just one?
Multiple versions of the test or just one? Yeah, I mean, there's multiple versions of the test, I'm pretty sure. Let's see here. So, But I would say this, like the multiple versions of the test, they should all be like a combination of the multiple versions for the quiz, if that makes sense. I mean, that's what I'm aiming for. I want all of the tests that all of the students take to test all of the material. That's what I want. Except for like the successive integer problem, because I ruled that out. So, all right. You guys had problems. A lot of problems on this problem. All right? If you have a paragraph of just words, you're doing it wrong. All right? You're doing it very, very wrong. We want to use the number line method, the zero factor property method, or whatever the book calls it. We draw our number line, we find the critical numbers, in this case -7, -1, and 5/4. Mark those on the number line. Here's a fun thing, an easy way to check signs. If you just think about putting like 1,000 into this, it's really easy to think about, because if you put 1,000 in for x, 7 doesn't matter, 3 doesn't matter, -5 doesn't matter. If I put 1,000 in, I've got like 1,000 times 3,000 times 4,000. Obviously it's positive, right? So that shows me I put pluses over here. And then I use the sign flip theorem. Since these are all odd, I flip the sign every time, plus to minus, minus to plus, plus to minus. To find less than or equal to, I look for minuses. Got them here, got them there. So I go minus infinity to -7, union with -1 to 5/4. And that's it. I include -7, -1, and 5/4 because I'm looking for less than or equal to 0. And the critical numbers here all make the expression equal to 0. They ought to be in the solution set. I also am pretty non-flexible. I will not give much partial credit at all unless you use interval notation. The answers must be written in interval notation. This is important. This one here is the less than absolute value problem, so it's easy. We just unwrap it as -2 less than 6 minus x less than 2, and then solve for x. Basically, you get 4 less than x less than 8, which gives us the solution set of 4 to 8. Again, I want the answer in interval notation, so I probably gave you some pretty strong partial credit on the quiz for this, but on the test I'm going to be more strict about interval notation for the solution set here. All right. If it's greater than, it's different, right? So greater than, means we have less than -2 or greater than 2 in this case. And so that gives you these two separate ones. That gives you either x is bigger than 6 or x is less than or equal to 2. And you take the union of these guys and that's the answer. So pretty typical. Greater than absolute value problem is going to have two disjoint solution sets. Oh man. My laser's coming apart. I paid like $2 whole for this laser. Yeah, like $2. But those were like 10 years ago. That was like 10 years ago. So I paid $3 whole for that. I mean, roughly speaking, inflation, But is it that time?
Yeah.
All right. Well, let me skip ahead to the one last thing here. So here, some of you just given me like lists of numbers. I don't know what to do with all that. I need intervals, interval notation. Give me my intervals, please. I asked nicely. I said please. So that's one thing. Intervals here. F of -2 is -6 because that dot's filled in. All right, for this one. It's perpendicular, so the slope is minus the reciprocal. I use point slope to find, yep.
What did you put -2 into to get -6?
It's the graph. The x value of -2, right there, -6.
Oh.
Right there.
What other ones dealing with lines and functions will be on the test, or will it just be problems like that?
This one here, we had f of -8 was -4. What would f of 4 be here? What would f of 4 be here? 0? No, not 0. It wouldn't exist is the right answer, right? See, you're like, it doesn't exist, so it's 0, right? But 0 is a thing.
Is it DNA?
A DNE, yeah, a DNE does not exist. F of 6 would be 6 here. Anyway, I was about to say have a good weekend, but that sounds wrong. See you at the test, right? Yeah.
These lines and functions problems